All right. So in the previous video, we installed the infrastructure for the OPSB suite, which means that it created a bunch of machines and all of the logic for connecting between those machines. So those are going to be worker nodes, Vertica server, Vertica controller server, the Bastion node, security groups, AKS cluster, Route 53, and everything. But we still need to deploy the ITOM platform, which is the topic of this video, right? So there are like three stages, let's put it this way. Stage number one, infrastructure. Stage number two, the ITOM platform, or OMT, it's your new name. And the next video would be how to deploy the OPSB suite on top of the OMT that we're going to install in this video. All right. So our starting point is, of course, the Terraform has finished, and we have all of those nice things. And basically, using some of this information, we would have to apply it to the environment. So let's just dive into it. So excuse me for going fast over here, but as you know, I always prepare because this is a test run of my normal work, and this is not just a side video of me doing some stuff. This is like a very important, but I do have everything prepared, and according to official documentation, the way that I should be doing this, the first thing would be to copy all of those nice certificates that were created by the Terraform to the Bastion node. And for some reason, I'm not able to do it. Why cannot I do it, really? I have no idea. But I'll go like this, and I'll say trust, and there we go. All the certificates are copied. Now, I also need to copy the OPSB suite chart, although the OMT and Vertica were copied there, but the chart was not, right? And now I'll just have to go to the Bastion node and SSH to it. And that's about it. Now I am inside the Bastion node, and I cannot go further. I mean, from Bastion node, of course, I can go inside the workers and I think even Vertica, right? But I'm like 2 levels in already. Okay, now I need to unzip some stuff. So first of all, I'm going to unzip the OMT, which was conveniently copied here by the Terraform script. And I'm also going to unzip the OPSB suite chart because I really need it. Okay, and there is a new script, or well, it's not a new script, but basically there is a script that allows you to configure the. You know, I'm going to stop it and I'm going to do this, right? So we would be able to see better. So the point is, I can run a script which sets all of the queries with the parameters that I need instead of running all of the queries and modifying them for the Postgres itself. So there we go. So do I want to use default values for SQL query creation? And I'm going to say true. Why default values? Because I don't want to specify every single little thing. There's like a lot of databases, and this is a POC environment, so everything would have the same password. What type of database that is? P for Postgres. Now include query true. Create database for OBM true. Monitoring admin true. I have no idea what it is, but I'm saying true for everything because if in case I change my mind later, right? I don't want to have troubles with the database and try to do stuff and modify. Instead, I'm just going to do everything from the get-go, and whatever I end up not using, that's fine with me, right? So I'm going to say true for everything that is not default, even though. Now, the system presumes that the super user role is Postgres, but by looking closely at the Terraform script, you'll see that it's actually dbadmin. So we're going to change it. And common password is going to be, need to be careful with that one. It burned my previous environment, right? So it's going to be this password. You know what? I'm going to type it just once more. Unfortunately, I cannot run this to confirm it. And there it is. Okay, fantastic. So now I'm going to run it against the Postgres SQL. And since Bastion is able to communicate with the database properly, although there are steps to validate it, I'm going to trust. And I'm going to say all of those nice things. And as you see, it just runs all of the queries that create and alter schemas, give permissions, set up everything that we need in the RDS instance. Okay, so now I'll go and type exit to go back to the init node. As you see, now I'm here again in the Terraform server, right? And I'm going to do some AWS related configurations. Okay, meaning that first of all, I clone the script because it needs to be executed in this folder specifically. And oh, come on, I hate it so much when I do that. Let me copy paste from here. Right. So it's going to ask me some questions. First of all, what's going to be the external FQDN? So it's going to be, of course, OPSB, student 83.opsb enablement.com. How do I know that? Well, I determined only the first portion, the OPSB, that's going to be it. Everything else is based on what I specified in the Terraform. The Terraform, I specified that I'm going to use this prefix here, and this is going to be my domain name for everything else. So here I just specify one more level, the OPSB. Okay, server certificate key. Now it asks specifically about those keys over here, but it's going to build ourselves something related to the Bastion node. So we need to give an answer about where it's going to be located in the Bastion node itself, which is where we copied it in previous commands, right? We copied some of the files to the Bastion, and this is where they sit. So there's going to be the server key, and that's going to be the server certificate. Come on, server certificate. And then it's going to ask for the root certificate, very important. Okay. Then it's going to ask for deployment name. And now it's going to ask for the organization name of the registry. Now, this is the confusing part because if you ever downloaded it or uploaded CDF images, you were using the HPSW item. But then where you were uploading them back to the internal registry for the on-premise farms, you're kind of not altering the name. But here, it actually means like what's it going to be the when I will go to some registry later, and I'm using a private registry, not the public one, because you cannot use the public one. The public one is provided by Microfocus. It's only for downloads, really. So you don't want to use that. Instead, I'm going to specify what is the internal registry that I already created and uploaded all my images, which is covered in a different video, but that's like basically a couple of commands that you need to run, and it happens. Same as download and upload images for the in-house installation. Same for the cloud, but the commands just a little bit different. We're going to cover it in a different video, but the point is that I created enablement. The name of the registry is OPSB enablement, and it's private one. It's accessible only from inside the clusters over here, from inside the account over here. Okay, database name unchanged, password, very careful. It never asks again. CDF database name, it never asks again. So the password is going to be as specified in the DB creation steps. And the region is going to be US East 2. And the account ID, well, the account ID for now, it's this. Doesn't really matter. And it created a couple of files. Let's see the files then. There we go. And now I need to copy those files to the Bastion node, right? There they are. And now I go to the Bastion node once more. I just press Ctrl R to repeat the command, SSH-I, and there it goes. I'm inside the machine. Fantastic. So now I need to copy the files that that I copied here to this folder, OMT, right? And now I'm going to enter the directory and list its content. So as you see, this is the one that has the /install. But if you remember, /install has a lot of dependencies, and it's no different here. So first of all, I need to go with pwd to get this specific partition. Why? Because the output doesn't know where I'm going to be using what's going to be the correct path to the config.json file, right? Of course, I could use the /home ec2, but I prefer to use it like this. Okay, and yeah. So we go with this. We save our work. Now we're going to cut the file. Okay, the install.txt. And now it has all of the information that we need to run it, right? As you see, I just need to copy it and I need to run it. And now it will ask me for the password. So I'm going to say the default password. And now let's see that I didn't make any mistakes somewhere. Because if I did a mistake with database, I'll have to just do Terraform destroy over the whole thing and then Terraform apply for the whole thing. Just because the database, I don't want to go to the database to clean it up from all kinds of things that it's going to do here in this deployment. Right, it goes to database and it's able to connect to one portion and alter it, and then when you run it again, it says, "Whoa, this database is not empty." And so, you cannot really redo too many things at some stages, right? And I'm saying it because, as you see, it says student 83. Well, I found it about this that I made a mistake with student 80 something, and I had to destroy the whole thing. Okay, let's see. Test external IDM database connection. I hope this works. I hope this works. Come on, it worked before on all my other runs, so something confuses it. Okay, that's good. Okay, I was very worried about this stage. Okay, and now we let it run. If you remember, the CDF installation was more or less it. This is how it looked like for the normal installation for the on-prem, and the only difference here is that it's a little bit faster because it doesn't bother with trying to upload images to registry. It already has the registry, so it shaves a few minutes. All right, let's see the end result. All right, there it is. It was actually very fast compared to normal installation. Now, before we continue, we need to wait a little bit. So I'm going to install the K9s, which is a super fantastic tool to control everything related to Kubernetes, just to view it. So there it is. And we see that for some reason, the pods are already running. They're not in the init state. They're just running. I guess this is the power of AWS. That is crazy. Oh, it's actually for running for some time already, and some pods are actually created by creating the cluster, right? So if you remember, we deployed in a previous video the whole infrastructure, and so some of them, according to the time signature here on the right, you see that's like 54 minutes, 64 minutes, 45 minutes. So some things did happen, and some pods were actually brought up pretty immediately during the installation. So yeah, we don't need it anymore. And we got ourselves some nice things, right? So first of all, we got all of those nodes. So I'll copy all of those nodes to site. I wouldn't need to use all of them, but just in case. And now we need to do some interesting things, right? So first of all, I'm going to run a script that creates the load balancers, right? So to recap real fast, if we will go to EC2 instances over here, and we'll filter for student 83, we'll see there's like a lot of things over here. Some of them are workers. And workers right now, they are not load balanced in terms of workload and everything. They are connected to the Kubernetes cluster, of course. I think we can see it here. Maybe I'm mistaken. Let me see. kubectl get nodes. I think they already. Oh no, kubectl get nodes. I think they already exist. Yeah, they already exist. But in terms of load balancing, going to the correct places and from outside and basically for everything to work together in terms of API calls and everything else, they need to be load balanced. So we need to create a load balancer on the inside. And if we will go to the load balancers over here, we see that there is only one for the workers, but we need another one. And I think this one is, which one is it? It should be mentioning one of them in terms of VPC. Do you have something in the tags that I can read? Which one is it? Oh, come on. Probably need to go to the VPC itself. So let's go to another window to see which VPC are we talking about, because I don't see its name. And I have no idea. It's DFE at the end. So DFE student 83 VPC. All right. So this is like the internal load balancer, but not for the external API calls. We need another load balancer. And I know that I'm going to do something weird because I'm going to run the command as it is, and it creates basically an internal load balancer. Now it lists that, I'm allowing access for all of those external IPs that we copied from the external access host and everything. It doesn't work because this is an internal load balancer. Internal load balancer doesn't have a public access at all, right? It just creates a thing like this. It creates the internal load balancer. It says internal, and it means that all external traffic from outside the world is useless. And I'm going to create another video trying to create an external one on the very first attempt. However, in this case, I'm going to use as many defaults as possible with some modulation, right? Because the point of the default setting is to provide as secure method as possible to the customer. So we cannot really blame them for making it a little bit inconvenient. At least it's secure. It wouldn't create a security breach unnoticed. Anything that you create with external access would be created manually on demand on purpose. So basically what you see, the output here, it fits the external load balancer creation, not the internal one, which we don't care at the moment. Okay, fantastic. So what is it that we need to do then? Well, it's very simple. While it is provisioning, there is a listener over here, right? And we can see the target group that it created for this listener, for this load balancer. And because we don't have multi-zone or anything like that, only one of those IPs would work. Okay, what is the problem with target groups? That when you have a target group like this, for port 5443, like we created, that it created, it basically allows assignment to only one load balancer. But I want to create an external load balancer, which would allow me to access this thing from the outside, right? So yeah, in this situation, we need to make some difficult decisions. But the point is this: for this video, we created infrastructure in a previous video. We deployed the OMT in this video. Okay, and we created the load balancer. So now all API calls for internal components, it all works. The question is, how do I go ahead and access the OPSB suite URL, the app hub here, to continue the installation? And the answer is, well, there are several answers to this. One of them is I'll go to the VPC for this OPSB suite and create a Windows machine, which would be acting as a jump server. Basically, I'm going to have a machine inside that I can RDP to it, and then it will connect to everything from the inside. And this is one method. Another method is for using the external load balancer for which we are going to have a different video because it's not canon, it's not official documentation, it's me making decisions, right? So I don't want it to be connected to the official documentation like this video is. And also I'm going to create a separate video for an attempt to create an external load balancer with a single command from the install properties of the suite. So that's going to be two different videos. So I'll see you in the next one.